All right, intervals of increase and decrease, we're back. First, we talked about how to do things in interval notation. If your teacher doesn't want you to do it in interval notation, and you're watching this and I'm not your teacher, then you can certainly do it in inequality notation. And the previous video should have shown you how those two interact with each other, what the equivalent would be in terms of inequalities versus interval notation. But let's talk about actually getting to the intervals of increase and decreasing, figuring out what they are. All right, let's say I have this function. It's probably a cubic. Here's a turning point, and here's a turning point. That's your first step, is finding the turning points. Where does it turn and go the opposite direction? It turns around and goes in a different direction than it was going. Was going down, now it's going up. Now it's going down. Each one of those is a turning point, and each one of those is going to be reflected somehow in your answer in terms of the intervals of increase and decrease. I'm going to go ahead and just randomly put some points here. Let's assume that I have looked up the graph and I pulled up my open Desmos, pulled out my graphing calculator, whatever. Maybe I was told. And I'm going to say that this is negative 2.51, negative 1.6. And I'm going to say that this is positive 3.4 and 4.71. All right, those are my points. Now, I went ahead and did that because when you aren't told specifically something other than this, a lot of teachers would prefer that you go to the second decimal place, which means to the hundredths. So I'm going to go ahead and give you an opportunity to do that. The biggest thing to know about interval notation is once you have established, okay, it's going down here. My guy is sliding down the mountain, so this is an interval of decrease. And this is an interval of increase. He turns, he's going upward this time. He was going downhill, uphill, downhill. Once you have established that, describing where each of those things happens is done strictly, only in terms of the x values. In other words, I'm going to say he's going downhill until he gets to this x value. I will not use negative 1.6 at all. I will not touch that number. Then I'm going to say he's going uphill until he gets to 3.4. Not going to touch 4.71. And then I'm going to say who's going downhill. Now, a couple of reasons for that. One is we're talking about this, reading it from left to right. Starting at negative infinity, going across the graph. So we always read our intervals of increase and decrease as if our guy is traveling across the graph from left to right. He starts at the left, going uphill or downhill, whichever, and goes across the graph from left to right. Left to right is x's. So if we're talking about things in terms of going left to right, we're talking about where you are in terms of x. We're moving along the x-axis. Another reason is, let's put it this way. Let's look at it. How about, for instance, let's look at x equals 0. When x is equal to 0, which is a vertical line, what's happening? Well, it looks like the graph is increasing there. In other words, when the graph crosses the point where x is 0, it's in a period of increase. What is the graph doing when x is 4? Well, here's 3.4, so 4 would be somewhere in here. It's decreasing there. When x is 4, it's decreasing. All right, so we can say that. How about if you tried to tell me what is happening when y is 2? All right, so let's think about that. Trying to describe what is happening when y is 2. And I'm going to grab a pencil or something like that if I can. Dead time. Sorry about that. I wish it were something skinnier than a pencil, but here you go. Here's y is 2. So which time do you want me to talk about? He's going downhill here, and then he's going uphill here, and then he's going downhill here. I can't tell you what's happening when y is 2, because y is 2 a bunch of different times. So that's the other reason we talk in terms of increasing or decreasing when x is between certain numbers. Okay, another reason is the word decrease is telling me what the y's are doing. The word increase is telling me what the y's are doing. The word decrease telling me what the y's are doing. So those words handle the whole thing of talking about y. The x values are telling me where that happens to y. Okay, so going across my graph from left to right, it is from negative infinity up to this point right here. And I'm going to draw a vertical line. I'm going to make it dotted. From negative infinity up to this point, it's doing one thing. What's it doing? Well, he's sliding downhill, so it's decreasing. So I have an interval of decrease from negative infinity to negative 2.1. That's an interval of decrease. Again, I'm using the x value only because I'm talking about going across the x-axis. Where is the y decreasing? When x is going from negative infinity to negative 2.1. The next interval, I'm going to pick up at negative 2.1. And this interval goes, he's increasing up until he gets to, what's the x value of the next turning point? 3.4. So from negative 2.51 to 3.4, we have another interval. This time, during that interval, it's an interval of increase. Finally, and we pick up right where we left off at 3.4, our last interval starts when x is 3.4 and keeps going across here until we get to infinity, so forever. And I put my parentheses and close it at infinity and say that that's a period of, the y value is decreasing during that period. So this is an interval of decrease here, interval of increase here, interval of decrease here. If you have 2 turning points, that means you're going to have 3 intervals. Just like if you took a candy bar and you cut it twice, how many pieces would you have? You'd have 3 pieces. I have cut my graph twice. The first section went up to here, now I cut it. Now it's going to do something different. Second section, go to here, cut it. Now it's going to do something different, and so on. Now, one thing you may be wondering is why did I use all parentheses and no brackets? I have seen books that use brackets. I don't agree with that. Why? If this guy's standing at the very bottom of the valley, maybe he's standing in a creek like we sometimes have at the bottom of valleys. Take a picture of him standing in that creek. You know, he's filling up his water bottle, whatever. Is he going down or is he coming up? Can you tell? No, he's not doing either. He's at the bottom. So I'm not going to include that point over here or over here. I'm just not going to include it, period. Same thing with he's standing on top of the mountain up here. If he's standing on top of the mountain, is he going up? Is he coming down? Well, neither. So I'm not going to include 3.4 for either. Notice again, I did not ever, in describing my intervals of increase and decrease, use this number or this number, my y values of my turning points. And neither will you. Okay, let's do another one. We have a graph, and it looks something like this. The upside down W. Okay? Possibly a quartic, probably a quartic. Could also be something to the 6th power, degree 6, degree 8. But we're not really worried about that. That would come into play if we were worried about end behavior, maybe. We might have to think about that, but not much. It's just really the fact that both ends point down. Now remember, this is not end behavior, so I really don't care what the ends are doing. I care about what's happening as my little dude is going from left to right across this graph, starting over here at negative infinity and ending up at positive infinity. So keep in mind that always means one of your intervals, one of your sets of parentheses is always going to have negative infinity on the left, and one of them is going to have positive infinity on the right. So here we have turning points. How many turning points do we have? 1, 2, 3. Okay, a turning point is either a maximum or a minimum. It's, in this case, I have 2 maxima. That's the plural of maximum. Both of them are local maxima, meaning they're higher than all the points right around them. This one's also an absolute maxima because it's the highest this graph ever gets. We don't really need to know that to do the intervals of increase and decrease, but it's information you might need to know elsewise. This is a local minimum. Okay, it's lower than all the points around it. So turning points are also maxima and minima. All right, so we've got 3 turning points. Take a candy bar, cut it 3 times. Not into 3 pieces, cut it 3 times, like chop, chop, chop. How many pieces would you have? You'd have 4. If you think about my graph, I have one thing happening in this piece over here, up to this line. Then I have another thing happening between here and here. Then I have another thing happening in this piece. And I have another thing happening here. So that's 4 intervals. Let's think about what the little dude walking across is doing. Starts out, he's walking uphill. This is a really tough uphill battle. So this is an interval of increase. It automatically changes to the opposite at the turning point. So this is decrease. This is increase. And this is decrease. Now, if I did not know my minima and maxima, or I did not know my turning points, I would have to go find them. I could go find them with my calculator. I'm going to pretend I know them and just practice writing it. So let's say this is at negative 2.12, 4.63. This one's at 1.89, negative 2.3, and this one's at, and I know this is not necessarily the scale, so don't cry if it doesn't look exactly like what I'm calling them. And this is 3.16. Okay, so those are my minima and maxima. Random aside, if you were actually asked for the minimum or maximum values, those are the Y values, because minimum and maximum are talking about height. This is the lowest the graph gets in that area, so it has the lowest height. This is the highest, so highest height. Here's the highest height over here. So if you were asked what are the maxima, I would say 4.63 and I would say 3.16. Your teacher may want you to include the locations, in other words, the x values. We have a minimum at a minimum value of negative 2.3. It happens at 1.89. But if you're not also worried about maxes and mins, don't worry about any of that. Let's just talk intervals of increase and decrease. So once again, my guy's walking left to right. He's starting over here. He's going uphill. He goes uphill until he gets to this point. What part of this point do we care about? The x value. Because we're basically saying when he gets to the place where x is 2.12, something changes. And then still moving across the x-axis, when he gets to the point where x is 1.89, something changes. And now when we get to the point where x is, sorry, it doesn't go right through there, 5.43, something changes. So our intervals are going to say from negative infinity to, that's negative 2.12. Then I'm going to have an interval from negative 2.12 to 1.89. Then I'm going to have an interval from 1.89 to 5.43. And then my last interval will be from 5.43 to positive infinity. So all of these things are x values. Okay, so let's go ahead and write them. From negative infinity to negative 2.12, I have an interval of increase. From negative 2.12 to 1.89, I have an interval of decrease. From 1.89, and notice these all match up. These two come together. These two come together. Now, they don't always have to. You could have a graph that's non-continuous, where maybe it jumps or something and it doesn't have to. But if it's continuous, if you can draw the whole thing without picking your pen up, then all of your intervals will join up. So this is from 1.89 to 5.43, and finally from 5.43 to infinity. Let me go back and talk about what those are. This was increase. So this is increase. And this is decrease. Okay, and usually the way you would list those is you would say increasing, and you'd list this interval and this interval. And then you'd say decreasing and list this interval and this interval. And that's how we do that. The one more thing I want to talk to you about is how to find those maximum and minimum points on my graph with the graphing calculator. I'm going to make another video part for that, so stay tuned.